This is video 4 of looking at permutations and combinations. And so we're at the top of the page here where we're talking about calculator tips. I'm actually going to save that for when we're together in class. And in this video, we're just going to look at examples 1 and 2. So now we're into problems where we need to think about, is it a combination problem or is it a permutation problem? In other words, does the order matter, making it a permutation, or does the order not matter, making it a combination? So for these problems, the directions do say you're going to calculate this without using any built-in permutation, factorial, or combination functions on your calculator. You can use your calculator just to use to do regular multiplications. And then it says once you found the answer, you can use the built-in functions. But again, we're going to save that for when we're together in class. So the first question says, how many 4-digit numbers can be made using the digits 5, 6, 7, and 8? All right, and notice in this one, it doesn't say that we can't repeat digits. So if we think about the problem, is it legitimate, if you have the digits 5, 6, 7, and 8, could you have the number 5,555? All right, we're making 4-digit number. Yeah, 5,555 is a legitimate number. So in these problems, repetition is okay. So repetition is okay. But the order does matter, doesn't it? All right, if you think about the number, 5, 6, 7, 8, that's different from the number 8, 7, 6, 5. All right, they're two different numbers. So these are permutation problems. All right, so for the first one, we have 4 digits, all right, and we want to make a 4-digit number. So if we just think about this one kind of the way we have before, we could say, well, for the first slot, there are 4 choices. Second slot, there are still 4 choices because I can repeat. Third slot, still 4 choices. Fourth slot, still 4 choices. So this is 4 to the 4th, which is 256. So I'll point out that that problem is actually like this problem all the way back here, where we were allowing repetition. So where we ended up with n to the r power. So in this case, we ended up with 4 to the 4th, or 256. For the next one, you do have to be a little bit careful about this one because we have 0 in our list. And if you think about making like the number or the choice 0, 7, 8, 9, remember we want a 4-digit number. And this is not really a 4-digit number. This is really a 3-digit number. So what that means is we don't really have 4 choices for this first slot. We can't choose the 0 for that first slot. So we really only have 3 choices there. All right, but now when we come into the next slot, it would be okay to have any of these digits, 7, 8, 9, or 0 in this next little slot here. And so I'm back to having 4 choices here, 4 choices here, 4 choices here. So we end up with 3 times 4 to the 3rd, which is 192. And again, you can use your calculator to do those basic multiplications. All right, the next one is, notice it says how many 4-digit numbers can be made using each digit only once. So notice that this one is not allowing repetition, so no repetition. We want a 4-digit number. We have 4 choices here. No repetition, so we can do 4 choices for the first, 3 choices for the second, 2 choices here, only 1 choice at the end. And so here we end up with 24. So I want to point out that this problem is where you basically have 4 objects and you're arranging them in any order and you're using all of them. So that goes back to this first type where we were arranging n objects in a row. All right, so here we had 4 objects, we're arranging them in a row. The next problem, notice that we have 5 numbers to choose from, all right, but we're only making a 4-digit number. So this one is going to be like the third type, where no repetition is allowed, but we're only taking some of the objects. We're only taking 4 of them. And recall that this one is the permutation. It's called the permutation of n objects taken r at a time. And here's the formula. All right, so we want to remember that formula. In fact, we'll come over here and write that formula down as we go through this problem. So remember that the permutation of n things taken r at a time is n factorial over n minus r factorial. Okay, So I want to think about this problem a couple different ways. So one is, again, I'm making a 4-digit number. So notice I have 5 choices here, 4 choices here, 3 choices here, 2 choices here. And so now if we multiply those together, we get 20 times 3 is 60, times 2 is 120 choices altogether. But I do want you to see that this formula that we have right here could have also worked. In other words, we could think of this is the permutation of 5 objects taken 4 at a time. We have 5 things, but we're only choosing 4 of them. And so according to this formula up here, that would be 5 factorial divided by n minus r, so 5 minus 4 factorial. So this is 5 factorial divided by 1 factorial, and 1 factorial is just 1, so we just end up with 5 factorial, which is 120. And if you'll notice, this is the same as 5 factorial, isn't it? 5 times 4 times 3 times 2 times 1. In the last one, this one we just have to be a little bit careful again about how we set this up. So we want a 4-digit number. We can't have repetition. So in our first slot, we would have only 3 choices. We've talked about this before. I would have to choose one of these. So let's suppose that we chose this one. So now when I come to this slot, notice that I still have 3 choices. Now I have 3 choices because I can take the 0. So I'd have 3 choices here. And let's suppose that we took the 0. How many choices do we have left for the next slot? 2. And then how many for the last one? 1. So this one's going to be 18.